Let's now look at the effect of compoundings and whether more compoundings per year mean more money. We're going to go back to that earlier example of $5,000 in an account earning interest compounded annually at 8% for 5 years. We had done this calculation a couple of different ways, once with a table and once with the formula, and the future value was $7,346.64. That would be with a single compounding each year. So we earn interest once a year. But let's look at the same scenario with different levels of compounding. I'm going to look at semi-annually, so twice a year, quarterly, 4 times a year, monthly, 12 times a year, daily, and hourly. And we'll take a look at this. So let's start with semi-annually. The formula would be 5,000 times 1 plus 0.08 divided by 2 raised to the 2 times 5, or 10. If you throw that into a calculator and calculate, you will get $7,401.22. So you'll notice that I've increased how much I've earned by, about $55. So that's a good thing. By compounding twice during the year, I've increased how much I have in my account by $55 after 5 years. So we do see that compounding more frequently is earning us more money. Well, let's see if we earn even more if we change this to quarterly. So if I earn interest 4 times a year, I would be dividing my rate by 4 and multiplying my years by 4. If I throw that into my calculator and calculate, I will get that I earn $7,429.74 each year during the 5 years. And so that, if we compare it to where I was before with semi-annually, is about $28 more. So I do earn more, but not as much as when I went from annually to semi-annually. If we keep doing this and we look at how much I would earn if I change this to monthly compoundings, so earning interest 12 times a year, my total after 5 years would be $7,449.23. That's an additional, approximately $20. So I'm still continuing to earn more, but not as much more as I compound more during the year. If I were to compound daily for an end value of 365, I would earn $7,458.80. Now I've earned more, but it's only about $9 extra. And then hourly compoundings, $7,459.11 after 5 years, and that hasn't hardly changed my total amount at all. If I went from 365 compoundings a year to 8,760 compoundings a year, you would expect that I'd earn a lot more interest, but I'm actually only earning less than $1, less than 50 cents really. Here, and I'll just approximate as $1, but you can see that initially the number of compoundings does impact how much I earn quite a bit, but it slows down. We seem to be reaching some kind of limiting behavior. And in fact, we are. Mathematicians can prove that there is a limiting effect of this compound interest. And in fact, the limiting can be expressed in a simpler equation. If we were to earn interest continually, so by the second, by the nanosecond, continuously earn interest, you would actually have a simpler formula. It's what we call the PERT formula. A equals P, P still stands for the present value, times E to the exponent of R, the interest rate, times the time in years. So we have a new exponent, R times T, and then what's really new here is this E. E is a number like pi. It's an irrational number, and because the decimals go on forever, we actually use a letter to represent it. But a good rounding off of E is 2.718. So E is a number between 2 and 3, a little closer to 3. And we use it as the base in this continuously compounded interest formula. Let's see what happens if we calculate this. So if I want to invest $5,000 for my present value, and I want it to earn interest that is continually compounded at that annual interest rate of 8%, I would use an E multiplied by the 5,000, but that E, before you multiply it, is taken to the exponent of 0.08 for the rate times 5. Now, we have an exponent that has a multiplication in it, and so we would want to multiply that exponent first before we actually apply it as an exponent. The nice thing is that the E, when you find it in a scientific calculator, usually comes up automatically in the scientific calculator with parentheses. And where to find it in a scientific calculator is that it will actually usually be associated with the button of ln. And that could be a lowercase ln or it could be an uppercase ln depending on your calculator. And if you look right above ln, you'll often see that the second function of that button is e to the x. That's the E we're looking for. And so what you would do to put this into a calculator is we would type 5,000 times, and then we would put this second function of ln in, which would get us the E on the screen. And then you would usually you would end up with a parenthesis. Many calculators automatically give a parenthesis as you type that in. And then we would do 0.08 times 5 and then close your parenthesis and hit equals. If we do that calculation, we will end up with $7,459.12. Compare that to where I was when I was compounding hourly. There's only a penny difference. A penny difference between compounding hourly and compounding continuously. And because of that, and because we have an easier formula, often when we get to many, many compoundings during the year, even daily, sometimes people will just approximate a scenario where you have many, many compoundings by looking at continuously compounded interest, because it's a pretty good approximation. These are pretty close to being the same. And this formula is a little bit easier.